First of all, let's start from brief review of yesterday's lecture. First, sorry, this is slide. First, yesterday we learned collection of field information from Dr. Terauchi's lecture. It means field sampling by yourself or getting data from existing database or publication. Second, sorry. Okay. Second, defining substrate class. You have to define seafloor as seagrass, seaweed, sand also. Third, creating features in defined substrate class. This is not yet explained, but Dr. Terauchi will add explanation. Features means points and polygons. They are made by software such as Google Earth and or QGIS. If you choose sampling by yourself, you will go to the sea to observe seafloor by underwater video camera and record location by GPS. Another way, you can also collect data from existing database. You have to define substrate classes from collected information. In NPEC, we usually use sparse seagrass and dense seagrass and mixed ones. And we have to define sand or sargassum also.
Okay, let me explain a little bit. Features can be in the form of points, lines, polygons, and these are the images of like points, lines, polygons, and you can use all kinds of like different shapes as a training data set. And this is another important thing to know. When you are preparing training data set, always be aware of the size of the satellite image resolution. In this case, on the left top image, A shows, this is a case of Landsat A operational land images, by the way. The satellite resolution is 30 meters. And our seagrass mapper have sampling scale functions to change the sampling scale. For example, if the sampling scale is set to 10 meter, as you can see in this C, the left bottom image, the polygon is finally regarded as your training data set. Because seagrass mapper is doing pixel to pixel classification, all the polygons or points data will be converted to raster image at the end. And this is something important to know. If you are using point information, seagrass mapper will just pick one point, as you can see in the right top figure of like this. So, well, this is just explanation. The details in guided in appendix of the seagrass trainer and seagrass mapper manual. Yeah, and yeah, it's very important to remember the satellite resolution, satellite image resolution, and the size of your polygons or points. Thank you.
Sorry. Thank you very much, Dr. Terauchi. This is today's lecture slides I made. First of all, I would like to give you an idea, outline of preparation process of ground truth data. For example, I showed NanoBay research survey. In the survey, we observed and record the seafloor by boat going around. And the track data is recorded as GPS track data. After going back to laboratory, based on the track data, the observed points are specified. This point, this point, this point. A group of points is surrounded by polygons and defined density. This is polygon. And defined density and substrate and saved in the form of KMZ Google Earth file for each polygons. It's a outline. This is the table of content what I explained. This lecture is divided into 4 sections. First, equipment for field survey. Second, research plan. Third, field data processing. Fourth, drawing polygon data and save the data. First, equipment for field survey. Necessary tools are these. First, digital watch, we must bring it, and field note. And one underwater observation device, such as video camera or underwater drone or water graphs is also good. And next, GPS logger devices. We have to log the tracks. So handy GPS or fish finder with GPS or RTK positioning system is also good. Depth measurement devices, rope or fish finder. And a small boat less than 1 ton is recommended because we sometimes enter shallow water. Of course, many batteries are required for each devices. And this is convenient tools. GPS devices, GPS display devices, handy GPS or tablet PC. If you use these display devices, you can go back to the same point in the future. And other operation record devices. It means video on board or depth logger for underwater camera. Mistakes and omissions in the field not always happen. To check our operation later, video or depth logger are useful. We can see what we have been doing by videos. And depth logger data also shows the rising and lowering of the camera moving. It's very useful. And since there is a lot of light at the sea, so it is also useful to have a shade for watching monitors. This is a photo of tools, a digital watch and video camera I will explain later, and GPS logger devices. At least 2 devices for safety, I recommend it for you. Sometimes GPS miss the logging, and not the recording capacity. We used the famous Garmin GPS at one time, but the cheaper models could not store enough data for our survey hours. For example, NanoBay, we survey for 10 hours. By 1 second, 36,000 points memories we need. Be careful about the memory size. And we use this I got you GPS in the field these days. And fish finder, you know, this deeper, it move with the smartphone and very small, but it's easy to get the depth, and portable is very useful, and small boat and convenient too. This is a depth logger from JFE Advantage in Japanese company. We set to the underwater camera. It's very useful too. About underwater video camera, I explained. We use custom-made cameras, which cost about $6,000 US, very expensive. It shows 5 directions at at the same time, allowing to see below and all sides for direction. It also records the video. Camera of the one direction is also good, but the recording function is desirable. Before field survey, please always check your watch before. You must adjust the watches of the survey equipment in second accuracy. Check your watch and video camera, GPS, and in case of NPEC, the depth logger. You should register survey locations on GPS display device before going to the sea. GPS logger is suggested to be set to record by 1 second interval if possible. How to write a field note. Of course, water-resistant paper you should choose and write with pencil. About recording items, please record the station number, the time you started to watch, monitor the seafloor, and the end time, and finished your observations time in seconds. You also have to record depth, substrate, and density of seagrass and remarks. Substrates should be sand, muddy, or rock, and any mix of them. The seagrass density should be written on a level of 0 to 5. Each level is shown in this table, but we actually record how many of 5 screens of our video camera shows seagrass at the same time. It is enough to know whether the seagrass is dense or sparse. So please be aware of whether you are recording more 3 or more or less than 3. In remarks, we record the type of sargassum also. It's a funny story, but be careful not to let the wind blow the field note away when the boat is moving. This is second section about research plan. The number of sites to be surveyed is not clearly defined, but a guideline by Japanese Fishery Agency recommends 60 training data points per 1 satellite for image. In our case, we surveyed 134 stations for 15 square kilometers. In short, 9 stations per square kilometers. About time, 1 point takes a few minutes. In Nanao Bay, it takes approximately 10 hours by 2 days for 93-kilometer cruise of 134 stations, including resting time. It takes a lot of time and we got very tired. About staff, we need at least 3 persons, boat operator, camera operator, observer of video, and recording note. This is a photo from the field survey, and this is a boat operator with handy GPS, very clever operator. And it's me, camera operator, and Dr. Terauchi watching, checking video. And I record the substrate with field notes. Very sunlight burn is very hard, so I use a very big hat. I show the, as an example, let's look at the underwater video of dense seagrass field. Five screens, we can see dense seagrass. And bottom is a little bit muddy. When it looks like this, it is recorded as a cover level of 5, very green and good seagrass. Okay. This is example of muddy water. Okay, let's start. Water is already stained, and seagrass can be seen, but it does not seem to be dense, the last one. In this case, we judged it as cover level of 2. 1 or 2 screen, we can see the seagrass at the same time. Sometimes we see 5 screens. We show animation of research crews. Start from here and going around and take a lunch, and afternoon we go again. The most of Nana Bay is shallower than 5 meters. We have surveyed points all over the bay, not just near the shore. Almost every 3 minutes, every 3 minutes, we raised and lowered the camera, moved from the one place to another, and surveyed 82 points in this one day. The repetition of same task is very hard. We had to check for omission in the field note, check operation of equipment, and check the battery level. It's very busy work. This is third section about field data processing. It's a most important part. Let's link, please link the field note and GPS information CSV file based on the time in second. It's very important, time in second for preparing training data set. Today we will explain an efficient way for field data processing. Exception case. number of stations is a few. This may be the method that many researchers seem to have done so far. By displaying GPS track in GIS software and by appearance track, you specify the observed points and surround them with polygons. This method is easy to understand and it's fast when the number of survey points is small. However, the size and shape of polygons will be different from analyst to analyst. Also, when there are suspicious places, it takes time to specify the point. It is quite hard work because you have to check the exact field note time with second level. After completing my first survey and processing the data of about 130 points, I nearly gave up this detailed work. So I came up with a new method which I present today. I believe that this method is better for more than 550 points. If you want to use seagrass mapper, this method will be suitable for you because it is recommended to survey more than 60 points when analyzing a single satellite image. My idea is to the field note time information. My idea is to use the field note time information to extract location data of observed points from all GPS data based on time from field note. The field note data should be made in this format: station, date, start time, end time, depth, substrates, density. And the GPS data should be like this: date, time, latitude, longitude. Using the start time and end time information in the field note, we can extract the observed point data from all the GPS data like this: start time, end time, and extract GPS data which we observed. This is an image of processing of many points. The location information is extracted between the start time and end time and combined. Extract and combine. It is not enough to combine the location information. It is better to combine the observation results such as stations and station number, depth, substrate, and density information from the field note to the location data. Combine, it's important. Extract and combine the observation result and make the one data set. In NPEC, we use our program to automatically process this extraction and merging of data. I repeated that it is important to record the time in seconds. In order to do this process, the time on your watch GPS video camera should be set correctly. It is also important not to forget note the time correctly in field note. I call the new dataset as polygonbase all because it is basis for drawing the polygons. polygon basis all means it contains all the classes of substrate. We divide it next step. Let's look at an example. For one station, such as 99, there are many latitude and longitude information. This is correct because the boat is drifting in the observation time. In addition, observed information such as water depth, substrate, and density are all tied to location information. It is hard work to draw different types of polygons in observed order. For example, this is sand. Next is seagrass level 5. Next is mud, and so on. It is very hard and confusing. To make the work easy, I divided polygon-based all data set into each class. This flow diagram shows the simplest way to divide the data into 4 classes. The first one is whether there is seagrass or not. Here, check the density is 0 or not. If seagrass is present, it is divided into class based on whether it is dense or sparse, with a minimum level of 3. For dense seagrass data, I named polygonbase dense seagrass.csv. For sparse seagrass data, I named polygon database few seagrass.csv. Next is the case where there is no seagrass. It is divided by presence of or absence of rock. It is if there is no rock, I named polygon base mat and mat sound CSV. If there is a rock, it is polygon base rock.csv. Now we have divided original data into 4 classes. I will talk about transcription mistakes. The more survey points you have, the more mistakes will occur. It is important to check the data transcription at least twice. In my experience, going back to the beginning of the processing many times by small mistakes such as transcription mistakes, it's just a waste of time. About the advanced technique, we think NPEC explores possibility of using the depth logger data as field note, such sometimes includes mistakes, and writing them and copy to digital data takes time, and mistakes sometimes occurs. If you have good idea for making ground truth data more easily, please teach us. This is 4th section about drawing the polygons. As in hands-on lecture, you will write polygons. It's easy exercise. So please listen. You will try this process later. Please, before going into the detail of the operation, I will tell an outline. First, display points from CSV file on each class and draw polygons. Polygons should be separated with different colors by each class. And output KMZ files for each class, and finally KMZ KMZ files of classes are ready to register by seagrass trainer. Now I will explain how to map CSV files on Google Earth Pro. First, drag and paste the one polygon base file onto the Google Earth screen. So, sorry for Japanese display. The data import wizard will launch. Just follow the flow and you will be fine. Please press next. And the longitude and latitude will be recognized automatically. You can proceed with next and finish. Google Earth will ask you about style template. For now, it's okay to say no. Style templates are advanced too. They can be a powerful tool if you use properly. And datasets are first placed in the pending folder on the left side. If you tick the checkbox on the left, it will appear on the main display. Please think of it as a layer. Now the points are displayed on the Google Earth. Let's zoom in. You can see several points. During the camera observation, as the boat was drifting, several points means the real movement of the observation point. So you can see that the data has been extracted correctly. If you click on a point, you can see information about it. It's very useful. I will explain how to check overview of created dataset by displaying tracks and points, and we have to check the location of the point of polygonbase or .csv. To display tracks, drag GPX file in the same way as CSV file. When working with the track in Google Earth, GPX file commonly used in GPS. I think it is rare using a CSV file for GPS data as we do for polygon-based data. For GPX file, you also should check the box on the left. Track information contains times, so please note the time slider. This image shows the comparison of the accuracy of two GPS and estimated observed point. First, as you can see, GPS data is wrong. Sometimes it happens. Second, approximately the time in the field note was wrong. So the actual point should be the corner of the track. Misestimated. So we have been processing the data without drawing, and sometimes wrong estimation happens. Please check this by drawing the whole picture and see that what the cause is. It would be the perfect if you could correct all polygon-based data set, but don't be nervous as it is just guide for drawing polygons. Please recognize that there is wrong point. I explain exactly how to draw polygon. At this time, the data set for polygon base should be choose should be the classed one. For example, polygon database, polygon base mat sand CSV I use. This is enlarged image. The points are lined up along the track. You can see the station number and of the points, but this is because I use the style template function. Usually points are simple dots without numbers. This is how to draw a polygon. Select this polygon symbol from the icon in the top left corner. This. Let's click left button and keep pushing and enclose the collection of the points. Please be aware of solutions of satellite image. Dr. Terauchi explained previously. At the same time, the property wizard is open and enter station number and select colors. The same class should have the same color. The color setting is the same for each polygon after one is made. You have to create a folder with the name of each class. When you finish drawing polygons for one class dataset, store all of them in it. When you save the data in Google Earth, selected object will be saved together in one file. Sorry. In Google Earth, you should save only one class as KMZ file. Go to File and Save As. In this way, you can save polygons from the same class together in one KMZ file. Now you can get the data to register with seagrass trainer. Finally, we have. I will explain the advanced technique of the style template. As you can see from the slide in the middle of presentation, Google Earth can display points and numbers in variety of colors and shapes using information associated with them by style templates. In this case, high coverage of seagrass is shown in dark green. This 5 means very dense seagrass. The depth of seafloor is shown in the form of polygons, pin and stars and vector. In this way, the result of survey can be visualized more easy to understand. That's all.
Thank you very much, Mr. Kozuka. I think the presentation he made was useful. I was very impressed by the speed that he organized data after we go to the field. I used to take like same amount of time, like for example, if the field sampling is taking 3 days, at least I was taking 3 days to get the data organized. By using the technique he just shared with us, he get the data organized within a day. Especially this sorting, screening a huge amount of data by matching the time of different equipment I feel it is very useful information for the participants here. So I would like to accept questions from the audience. And I'm pretty sure you have your own approach to get your data set organized. And if you know any better way, please share with the participants in this webinar. If you rather talk, please raise your hand, and so that please unmute yourself and talk if necessary. Okay, if no one's asking questions, I might appoint someone and ask one of your experience. Second, I see. Kirill Bazarov, can you share your experience if you're listening?
Hello, I'm here. What do you want from me? Hello?
Hello. Sorry. I was, yeah, I hear you very well now.
So what do you want from me?
Oh, yes. When you go to the field, how do you get your field data organized in your case study site? Do you use some similar technique just like he just showed to us?
In our past work about mapping seagrass, my role in this work was a cartographer, and I was a GIS specialist. So I didn't have a part in field work. The field works, the ground truth data, was obtained by Vasily Zharikov, Dr. Vasily Zharikov. So unfortunately, I cannot tell you some
Okay.
Something about getting of ground truth data. In GIS, I created point shape file with information about depth, type of bottom cover, seagrass, sand. In last walk, we have only 3 classes in our book. It was dense seagrass, sparse seagrass, and sand. And we used shapefile, point shapefile.
So you usually create that GIS data, I assume, using QGIS or some other?
No. In our work, we are using ArcGIS.
ArcGIS. Okay.
Yes.
Okay. Thank you for sharing your experience. So Kirill is obtaining information from scientists and making GIS data on top of ArcGIS software. Okay. Maybe one more person. Soo Young Ko from Busan National University. can you share your experience about getting data organized? Yes, please unmute yourself or turn on your video if you like. Oh, okay. Yeah, I see. Okay. Yeah, a question coming in the chat. Is it necessary to correct depth information because the different water elevation in different time related to the tides? I will be explaining a little bit about tidal correction in my next presentation. Yes, of course, it's important to know the depths, and the depth changes by the time if the ERK study have a huge tidal effect. I will be explaining this thing. I see someone raising a hand. Second. King Lau, can you unmute yourself and talk?
Thank you for your for my question, because I have a question for about the field survey data. We got a problem that how we can determine.
Your voice is very small. Can you increase the audio level of your microphone?
I'm sorry. Can you hear me?
Yes, clearly now. Yeah.
Yeah, because you know in Vietnam, especially in Vietnam, we do not have enough equipment for the field survey. For example, the camera, underwater camera, to record all the chip. So we just do by station, right? So you know, one station, just only one point. One point on the set on anywhere, right? One point, but the image file is for Landsat is 30 meter and but 30 meter, for example. So how we can determine that pixel it belong to seagrass? Sand it's more easy, and other sea width, because normally seagrass and sea width combine together, right? It's very difficult to separate. It's so I consider, I wonder, when you let's cut the row, the field chip around your bay. So how you can determine that pixel is belong to seagrass, that pixel belong to seaweed, and that pixel belong to sand. And on different scale, on Sentinel image is 10 meter and Landsat 30 meter, and maybe more Econaut and some is very detailed image. Yeah. Thank you.
Yeah. I understand your concern, and this explanation was done in one of his slides. I explained that always be aware of the satellite image resolution, because every point in this seagrass mapper case will be converted to raster data before making the field data as a training data set. So even there are many substrates in one satellite pixel, you have to make a decision to pick one substrate that represent the location. Did I answer your question or concerns?
Okay, thank you. Because I know this is difficult. It's difficult even because I'm working on this for a long time already. But
yes.
up to now, I also don't know how to because sometimes it's not very clear to separate. It's subtraction. It's subtraction. Sometimes some area they are rib only, the rib and very few sea rib also, but the image spectral is quite similar. But, yeah. So because you have a very good equipment, I think, because the camera with 5 direction, you can see around that area. That good, I think. But it's too expensive. It's $6,000. It's too expensive. Okay, thank you.
Oh, thank you very much. Maybe Komatsu Sensei, are you here in this room? Okay.
Yeah, I understand. Kinro, I recommend to use GPS in the the zip bag, plastic bag, and on the head, and you swim, skin diving is okay, and you know the time, and so GPS always records the location of the diver, and the skin diver notes the bottom continuously. So you can get the continuous data. If the water depth is shallow, you can take like this without boat, nothing, only a GPS and plastic, how do you say, the plastic plate, you write the note during the swimming, and after that you make this kind of, the Mr. Kozga introduced the method. You can make this kind of data set. I think it is possible.
Thank you very much for the suggestion.
I can, sorry, Genki, I can share to what we did last
Okay.
year.
Yeah, thank you.
So we had both exposed meadows and so intertidal and subtidal. So intertidal, we just walked, but before that, so before we started walking, I would download the satellite images and then kind of have the points, pre-recorded points, so we know just approximately which way to go. And then because you would see on the image what color it is, so you would just basically go around that area and then record. So if you have a pixel which is 30 by 30, we would record a couple of points in that area. And then we would move to the next one. So that's what we did for intertidal. For subtidal, we just had a boat, again, pre-recorded the points on the GPS, and then we would have a diver, and then the diver would jump into that point, and then around that point again, we would have a couple of points, and then he would take pictures. Because we don't have a camera with 5 angles, so he would just take pictures around it, and then he would estimate what kind of habitat it is and the coverage.
Yeah.
So basically 1 pixel would have 3 or 4 points, just to be sure that we cover a larger. It's not like specific points, but we can draw a polygon of that. And then the images, we have the underwater camera that actually has the GPS. So each image has specific timing and the GPS recording. So we would know.
So let me just confirm my understanding is correct. Go to the field. When you are working with divers, the divers get multiple points, and with these multiple points, you are making polygons.
Yes, yes.
Okay, yeah, I understand it correctly. I think it's bringing the map or digitized map or image is very useful. We often do it.
Yeah, definitely. It definitely helped to have pre-recorded points and pre-field map, the
Yes.
satellite map, so you would kind of know which areas are problematic and which areas are easy to understand what it is. Even it was the first time on the field, we would just mark the areas which are much harder to distinguish what it is. And then if it is much harder, if I, for example, if I completely don't know what it is, we would have more points around it to successfully say what kind of, is it a mixed ecosystem or something else.
Yeah, thank you very much for sharing your experience. Yeah, I want to summarize that at the end of the day, you need to claim your ground truth data is collected in like certain rules. This is important when you publish your work in form of paper or technical report or something. So we just shared our method, and Mr. Kozuka has prepared the data set to work on. In the chat section, you see a message from him to download the data set we have prepared. So if you have downloaded this data set, please raise your hand. We will be doing a little bit of exercise using the data he has prepared. The link is in the chat menu. I will be copy and paste it again. Okay. So Mr. Kozuka will be explaining again using the data set he prepared. If you have time, please try to follow what he's doing. Okay. He will be using Google Earth this time, but the same thing or similar thing can be done using QGIS or other platform like ArcGIS. I'm just waiting for him to share his screen. Please wait for a second. Sorry for the trouble. Stop. Okay. Sorry, taking a lot of time. Now I will be hand over to him.
Okay, I will show you. Sorry. I will show you how to draw polygon. I'm not good at explaining in English, so I show you. Okay. First, the drag and drop the, for example, polygon base dense seagrass CSV, and the wizard data import wizard comes up, and push next, and latitude and longitude is recognized automatically, and next the finish. For style template, for now, no. And zoom in. And at this time, we cannot see the point. So we have to tick the checkbox in the folder, this. And this time we can see the points, and more zoom out. From here, we write on the board, and first we check this point. And if you click the point, you can see detailed information. This is the station 100, and other information you can check. And you can see the density of 5. It's a dense seagrass. And how to draw a polygon? You should choose the polygon icon at the left side, left upper side, check, and the wizard comes up. And if you have mistake, please click the right click. Oh, no, cancel. And one more time, push the polygon icon and check the group of points and click left side and push and make a circle. Okay, and you should put the station number and change the color. It is dense seagrass, so I use the very dark green. And okay. The polygon was made. For example, the 100 station 100 is registered in the left side. In this way, you can write many polygons. This is okay. This may be 99. Okay. And next time you have to make a folder in the Google Earth. You can choose, sorry for Japanese, you can add contents and select folder and make name, dense seagrass. Okay, I made new folder and drag and drop the new polygons in the one dense seagrass folder. You can check, yes, the polygons were in the dense seagrass folder. And how to make KMZ file? Please first uncheck all the folders and only for the folder you want to make file, you should choose. I choose dense seagrass folder and go to file and save as. This is save as. And dense seagrass KMZ. It's good name. And check confirm the file name KMZ. It's okay. And so please save and check the file. Where is? Huh? Sorry, I can. I found this is the file. Let's see. Right, desktop. Can you see the dense seagrass.kmz file was made? It's a process of the how to make KMZ file. That's all.
Okay, thank you very much, Mr. Kozuka. I think you understand how he is creating the training data set by reading the station geocoordinate and then giving the information of the substrate. Okay, so this, I think I'm pretty sure you have your own way, and there is no standard method for this one. But at the end, it's very important to match the spatial resolution of the satellite images of with your ground truth data set. Okay.